like our countries, like there's no protocol, there's no police, you can almost go everywhere.
The way things are going, it might change, right? They might start giving protection to, like whatever happened, I think 2 years back, it might happen soon that it is not welcome. You make it welcome because usually nothing happens.
It's usually along or. Or protection, never realize something bad just happened.
Mhm. I think there's so many people disoriented.
They come.
Yeah, I saw them there and I was thinking, I'm pretty sure I'm in the wrong place. Aryan did not show up. They are in another room.
I think they have a meeting with Dr. Shiva after that. They're not.
Oh, they come after that. Yeah. So 1, 2, 3, 4, 7, yeah, 3. I think Maz said he was not well. He wrote an email to me saying he's not feeling well. So he probably, or he wrote to me saying that he will not be. Oh, I have to release the homework. I have not done that yet. Let's see. Homework 7 is due today. Homework 8. I'll make it due Tuesday, so 28th. I have not posted this yet, but by evening already. But I want to change the question a little bit. I want to rephrase the question. I will edit it a little. So that's the reason for the delay. Let's make it March 28th. That is a midterm 2, which is on is this really correct? April 20? It seems like I really another course has it on the same day. I try to avoid having 2 exams on the same day. So maybe I did. Also, final exam. Yes. Yeah. Okay. Okay. So typically final exam dates are not out in the first week of classes. It takes about 5th week of classes that it is released. So by now it is out and it is on Friday of the exam week. And it's the first exam on the day. So it'll be in this room. This is just for your information. Do cross check. There is a chart that you have. If you search SIUC example, do cross check on that. Something that we can fix. That's just for your information. I won't do write that every day, but it's good for you guys to know that. I expect the final exam to be take home. That's a kind of information, but not necessarily. Let's not make it. Let me not comment on that. But probably might be take home by then.
Can we start at 8:30 for the final exam?
It's 8. I think usually it's at 8 o'clock. 8 to 10, then 10:15 to 12:15, and 12:30 to 2:30, and 2:45 to 4:45. That's all it's something. At least for the last few years. So you think it is at 8:30?
No, it's just if we can make it 8:30.
Oh, you want to make it at 8:30? Let's. And why do you want to make it late?
Too early, 8.
Oh, too early. That might be difficult for various reasons. First reason is that there is a law in the university that says that exam cannot be changed unless all of you guys sign and give it to me in an official letter. That's one thing. The second thing is that if we start at 8:30, finish at 10:30, I suppose. I have a second exam I'm giving on 10:15. So it just really overlaps. That's the second thing. Third reason why we need not be discussing it too much, that If it is a take home, we don't have to worry about that.
Okay.
Right, so, yeah, ask me again, like, let's say about 1 month in April 15th or so, yeah, that's a good point.
So it will start on Friday or it will, we have to submit?
If it is a take home, let's say it has to be due by 10 AM.
Okay.
If it is a take home, it should be due by 10 AM, that's how we can make it. Right, but then I will make the questions available 1 week in advance. If that is the way I'm going to do it, but this is what I intend to do. As far as you guys all work the way you guys work for midterm one, where there was a lot of consistency, where it seems like you were working for the stuff. But if I start seeing that only one of you needs to be not working, and then I have to assess that particular student, and then I have to do it universally and make it fair. Okay, so that's how typically I go by that. Okay, reasonable. Yeah, there is one more thing, and that is related to March 28th. The class on March 28th. It is Tuesday, next Tuesday. Now, what's happening is that there is a set of 500 students coming to the university, they are high school students, and from 12 o'clock to 2 o'clock, they are needing help with making physics demonstrations available to the students. It will be in the stadium because there are 500 students, so they will be opening the SIU arena, or it's called the Pantera Center these days, and the department has to assist with that demonstration, basically make some nice cool stuff available for high school students. So there might be a telescope setup if things go well. We also have a planetarium, do you guys know? So there is an inflatable planetarium the department has, but I don't know whether that will be possible to set it up because we need Bob for that, and Bob is too busy with other stuff. He's going to Australia chasing an eclipse, right? So I don't know about the planetarium, but the telescope I think we should be able to handle, and other demonstration stuff. So it lands on me, so it is between 12 to 2 o'clock, so I will probably be there to assist with that. So that leaves the class on you guys, so I am thinking what to do about that. Any suggestions you have? And
We can go with you.
We can help you there.
That's good. Actually, I was looking for volunteers, but then I cannot use the classroom for that. If you guys assist me, then what I was thinking was that I will let you guys leave the classroom. Like you guys have the classroom and then give lectures to each other, 10 minutes. And since we have recorded lectures, so I was thinking I will ask you guys to go over it, and every 5 minutes you take turns in giving lectures to each other, right? That'll give you some experience, and then I will look into, usually you guys look into the recording. This time I will look into the recording and just grade it as a homework or something. So that's what I was thinking. I'd never done this before, but I was thinking that's something I could try. But if you guys are, I do need assistance with the stuff. If you guys want to do that, but then you still have to do this in a personal setting somewhere, which is harder for you guys to come together in a group. Okay. So let's decide by Thursday. Any other suggestion of those? That was a good suggestion. I like it because I was interested in volunteers, which I will write an email, or I'll probably approach some students. I was thinking of asking Dustin. He was very helpful last time. He's good with hands-on stuff. But if you guys offer, yes, I will. Can you take that?
Yeah.
For the class, I was thinking if it's exactly like the last year's, we can watch one of the videos.
Yeah, and then I'll give you a homework associated with that.
Right, the lecture notes.
Right? Is that I'll see which video will fit into that, and and try to do that, and how important it should be. That's also, if it is something basic like Green's function, which is what probably will be falling on that day, I really don't want to skip it, so maybe I'll repeat it a little bit here and there also, so, okay. So, yeah, I'll decide by Thursday or something like that, and let you guys, so you guys are open both for doing a homework based on a lecture that I ask you to see or watch, or doing something as an activity together.
Yeah.
Okay. Okay. And you're also, are you guys, if I take up Abdullah's word of volunteering, he will volunteer, are others interested?
Yeah.
Would you be able to help? I'll make it optional if at all it is. I think I should make it optional. I shouldn't ask you guys to come there. I think that won't be fair, I guess. Yeah. But
Okay.
that's it. It'll be an experience in the sense if you have ever interacted with school students, sometimes they can be annoying, but sometimes it's when they see this stuff, they get excited too. So if we can do that, that's okay. So that's the. Yeah, I have to decide on these things. Okay.
How many more sessions do we have left?
We have 8 weeks. We are halfway. Spring break is exactly in the half, except that there were 8 weeks that is over. We have 8 weeks remaining, but the last week is exam. So we have 7 weeks. So
We have April, half of May. March.
yeah, 2 weeks in May, 3 weeks, 4 weeks in April, and 1 week in May. Yeah, so that's 7 weeks remaining. It's the second week in May. So that's how it is. Yeah. And out of that, 4 weeks will be radiation and 2 weeks probably scattering. So that's wanted. Okay. Anything else? No pointer? Okay, so we started writing the electrodynamic equations in relativistic notation. I thought I will do a little bit more on that. It's sort of good. We can connect with whatever we did earlier. In the first week, we talked about energy and momentum associated with electromagnetic configurations. It doesn't really have to be electromagnetic wave. Electromagnetic wave is a particular configuration, but for any electromagnetic configuration, you can associate an energy, you can associate a momentum, and we talked about conservation of those quantities. But all that was done in vector language, right? We talked about Poynting vector, we talked about momentum density, but it's good to see in a relativistic context, how do they transform? Like what happens if you go from one frame to the other. So let's build on to that. And for that purpose, let's go back and see. So this is true. And 4 vector notation. Notice that then there's nothing new I'm going to talk about. It is going to be the same content, but we will see it from a more general prescription. First one was for potential. If that's what we defined last time. We said A mu was defined as 1, so phi, and there was a vector potential A. So we said that these two come together. There's a electric scalar potential and magnetic vector potential, except the dimensions of these two do not match. So we have to put in a C somewhere. So that shows up here, 1 over C. So that was the definition. Then we talked about, so that's for potential. Then there is the field tensor. sometimes we call it Maxwell field tensor, which is basically the electric and magnetic field. And we said this is F mu nu was defined as E mu A nu minus D nu. So that's your phi and A. This has electric field and magnetic field in it. And we actually evaluated this, worked this out, and we checked, or how do you say this? I think the best way to say it is instead of writing the whole, yeah, let me write the whole matrix, why not? So C F mu nu was equal to 0 minus E1. Was it minus here? Or was it plus?
Minus.
Minus, okay. So that's 0 C times B3 minus C times B2, 0, and C times B1 and 0. And this is an anti-symmetric matrix, so once I get one side, the other side is decided on its own. So that's your Maxwell field tensor. Then we also have pole current, right? And that was J mu. That's equal to charge density rho and the current density J. Again, these don't match dimensionally. We have to give speed to that. Speed times current density is the, speed times charge density is the current density. And in terms of this, the Maxwell equations are, so Maxwell equation actually only two of them. In homogeneous, so equations are G nu F mu nu is equal to J mu, except there is a mu naught. Yeah, not a very good choice of, let me change this to alpha beta so that the mu doesn't show up again. So this is D beta alpha beta. If I use mu, then that's a mu naught there, so let's avoid that. Use alpha beta. And what's the mistake in that equation?
Minus you know.
Oh, no. I actually switched this. If you're comparing with my notes last time, alpha and beta probably was switched. This
Should be J alpha.
J alpha, right? Beta is summed over, so the free index is alpha. So that's alpha. And what do I mean by inhomogeneous Maxwell's equation? If I set alpha is equal to 0, that gives me del dotted with E is equal to rho over epsilon naught. And if I set alpha equal to 1, 2, or 3, that means alpha is equal to I. That's a vector equation. Then I get del crossed with H and minus of d by dt of epsilon naught times E is equal to J, right, or mu naught times J. Just J. But that's not the only two Maxwell's equation, right? We have two more Maxwell's equation, and the question is, where are they? Right, this is not a complete story. What about So what about del dot B is equal to 0? And what is the other equation? Del crossed with E. And let me write this to the left, so that's equal to 0. It's inhomogeneous in the sense that when I put all the electric and magnetic field on the left hand side, there is a source on the right hand side. The current and the charge density is the source of electric and magnetic field. That's what I mean by inhomogeneous equations. These equations are not having any source on the right side. What that means is that that's a constraint on the magnetic field itself. Whatever the magnetic field is, it always has to be divergence free. That's a constraint on the magnetic field, no source, nothing. So it's a homogeneous differential equation. And magnetic field has to have that constraint. And similarly, electric and magnetic field together has to have the constraint that the derivative of time derivative of one should be equal to the curl of the electric field. So the question comes, where is this in this structure? So this is not a complete story. We need to investigate more, right? So where do you see those equations? For that purpose, so we construct a new tensor. So we call it the dual tensor. Dual field tensor, and that's written as F tilde, let's say mu nu is equal to, I'm going to define a new tensor now, that's equal to 1/2 times epsilon mu nu alpha beta times F alpha beta. So I start from the Maxwell field tensor and build this using this. This is a Levi-Civita symbol. Remember, we had epsilon ijk. Epsilon ijk was equal to +1 for epsilon 1, 2, 3 plus cyclic components. Is that clear what I mean there? I start with epsilon 1, 2, 3 is 1. And then if I swap once anytime, then I change sign. So cyclic means I can keep going. Let me not use the word cyclic. Plus even permutations. Because cyclic nature works only for 3 dimensions. I'm going to go into 4 dimensions very quickly. So this is -1 for epsilon 2, 1, 3 plus even permutations. And this is equal to 0 otherwise. This was Levi-Civita symbol in 3 dimensions, right? 3 space dimensions. Epsilon mu nu alpha beta is a 4-dimensional permutation symbol if you want. This is equal to +1 for 0, 1, 2, 3 plus even permutations. This is equal to -1 or let's say 1, 0, 2, 3 plus even permutations and 0 otherwise. Is that clear what I mean here? It's exactly the generalization of this. I have to start with one notation. So I start here, you say 1, 2, 3 is positive. Here, remember, 1, 2, 3 doesn't matter whether it is up or down. Here it is necessary that it is up. So I've chosen, I have normalized it in a sense by saying that the upstairs one is +1. If so, this quantity is 0, 1, 2, 3. Remember, every time I change the time index up or down, I gain a sign. So this one, 1, 2, 3 is space. This is time. So this will be -1. Okay. So all those features are in here. Any questions? Yes.
Like that equation is given or
This is a definition. So like this was a definition. And now the question comes, what is this means, right? So the moment I say that this is a definition, Where is this? I already have electric and magnetic field in here. So what is this equation and what is it about? We will see that in a minute. Okay, yes.
What is the case for zero for the? Any example for when it becomes zero?
Oh, here, so for example, 1, 1, 3. Anytime the index repeats, it's zero immediately.
And for this one?
Same thing, anytime it repeats, so 0, 0, 2, 3 will be 0, epsilon 0, 1, 1, 3 will be 0. Anytime an index repeats anywhere, it is 0. So even permutations plus anything else is 0. Is that clear? So way to remember it is that all 4 have to be different. If you fix 3 of them, the 4th one gets fixed automatically. If you fix 2 of them, there are only 2 freedoms there. Is that clear? A cross product has two components, right? Ax, ay minus ay, ax. That's because of I fixed the one component and then I'm left with 2 of them. So good point, good question. So is that clear? Anything else I should say there?
So whenever we're repeating one of the indices, it's 0.
Always, yes. Yes. So that is where this otherwise shows up. Like even permutations will play with this all 4 around. Others around everywhere else, it will be having at least one will repeat. Okay. Okay, so I want to build this. So let's set so since this is also antisymmetric, right? This by build, this is since these are even permutations by construction, this is antisymmetric. So this will be antisymmetric. F alpha beta, remember, already is antisymmetric tensor, antisymmetric in the sense if it is diagonally to 0 and only the non-diagonal terms are relevant. So let's ask what is F tilde 0 I. Right. That's these 3 components 0, 1, 0, 2, 0, 3. Right. That's for F mu nu. Here we are talking about the dual of that tensor, and that's equal to 1 by 2 0 I alpha beta and F alpha beta. So I fix mu and nu here. I'll fix that on the right hand side also. I've already chosen 0 now. So one index I have fixed. Since I have fixed 0, rest of them has to be 1, 2, or 3. I cannot have anything else. Out of that, I have fixed I. So alpha and beta cannot be 0 for sure. So it has to be j and k. So it has to be space components. So this is epsilon 0 I jk f jk. Remember, alpha, beta, gamma, these are all Greek letters. They go from 0, 1, 2, 3. And Latin indices, I, j, k, go from 1, 2, 3. So this is Greek and that's Latin. All the Latin letters, whenever I use, it's understood that it is going from 1 to 3. Whenever I use Greek letters, I'm going all 4. Is that clear? So here I am suppressing, that is, this was summed over 4 indices, but it cannot be 0 because I've chosen 0. That will always be 0. Right, so whenever I choose 0, that will repeat the 0, so it is 0. Okay, so I've used that property. I think Abdullah was asking what happens to the example, so that's an example I've used it. Okay, good. So that's FJK. Remember, if I've already chosen 0, that's epsilon 1 to 3 is equal to, where is that? Where did I fix that? Oh, I didn't. Oh yeah, it is +1, right? Whenever this is equal to +1, since 0 is fixed in that place, that's the same as epsilon ijk. Once I fix 0, the permutations possible are only in ijk. So this is the same as epsilon ijk fjk. And what is fjk, if you remember, was what was fjk? What is
H P.
It is a magnetic field, correct? There is a C on both sides. I can get rid of it, but it is not B itself, it comes in this weird construction, right? 3, 2, 1, and that comes with the Levi-Civita symbol. So that's equal to, if you look at your notes before, this is equal to epsilon jk, and let us say M, right, and BM. This was the construction you had from here, right? What I'm using is F0I is equal to minus EI over C, and Fij is equal to epsilon ijk ek. Is that correct? I hope I'm not making an error. Let me check this. Yes, it's okay. What is this equal to? Remember, anyone?
Delta I can.
Good, good. So
Okay.
two of them are summed here. JK is summed, right? So JK is summed over. When two indices are summed, it gives you a factor of 2. There's already a 1/2 factor of 2, and whatever is remaining is I and M. So it's I, M, PM. Correct. 2 and 2 cancel out. M contracts, and what you have is BI. So what we are learning is that the 3 components here are the magnetic field and coming with the opposite sign here, but this is upstairs, right? Remember, when I make it downstairs again, it will make it negative. So let me make it downstairs. So F tilde 0I would be equal to, these are space indices, doesn't contribute any signs. This contributes a sign, so this is minus BI. Okay. Clear? I do the same thing now for the IJs, right? Well, where is this?
What was the tilde for?
Tilde is a new, let's say, I'm building a new tensor. I can call that G if you want. Like sometimes you call it G, capital G. But we use the letter G for the momentum density. So limited number of letters, so I'm starting to use tildes. And sometimes you use star, F star in some books. I'm using tilde. Is that the question? Why tilde?
Yes, and we learned that it's B for if it's superscript. It's BI.
I did not
If
understand.
it's superscript, it's BI.
Correct.
And if it's subscript, it's negative BI.
Yes, yes, if it is contravariant, yes, or upstairs, it is this, downstairs, it's this, yeah, correct.
But it affects only for the time component, right?
Correct. Oh, you mean to say this is the same, this doesn't matter whether it is up or down, since I wrote this down, I'm bringing this down, it doesn't matter that I put this. But this is 0 has been moved, that's it.
That's why the minus sign.
That's why the minus comes, yeah. Was that different what you asked?
Yes.
Was there any confusion?
No, it's
Okay, clear.
okay.
Clear. Okay, so I need to do the same thing for Fij, so this is F tilde, let's say Ij now. That's equal to 1/2 epsilon Ij. And this is still alpha beta, F alpha beta. Now I have not chosen I0, right? 0 is still remaining to be chosen. When I write Ij here, that means that it is a space index. So I have the room to select 0. So I first choose 0, let's say in alpha. So this is Ij. Leave beta as it is. So 0, F0 beta. And that is a space index. So this is epsilon I j k beta Fk beta. That clear? So I leave beta alone, I'm summing over alpha, alpha is 0, 1, 2, 3. 1, 2, 3 is in K, and this is 0. Any questions there? This is index notation really coming into picture. If you're not completely fluent with it, you should ask me, I can elaborate.
I got confused with this.
Yeah, okay. So remember alpha, so this is, let me do it this in detail. So F tilde Ij is equal to, what that means is that there is a summation over alpha going from 0 to 3, summation over beta going from 0 to 3, epsilon Ij alpha beta F alpha beta. That's what this means. Let me keep beta as it is, and this is beta equal to 0 to 3, and this one now, the sum of alpha is equal to Ij 0 beta F 0 beta plus epsilon Ij 1 beta F 1 beta plus epsilon Ij 2 beta F 2 beta plus 3. Is that clear? But 1, 2, 3, I'm going to use Latin indices. So this is the same as epsilon Ij 0 beta plus sum over K, this time running only from 1 to 3, epsilon Ijk F K beta. Is that clear? Then I drop the K because summed indices mean, summed K means it is running from 1 to 3. Remember, Latin index goes from 1 to 3, Greek index goes from 0 to 4. So this was going from 0 to 4 because this was Greek. I switched from 0, I separated out, and I kept the Latin one. Is that clear? Very clear. So that's a general thing you do in index notation, but once you know it, then you know it, otherwise you stay confused. But it's a trivial thing, it's just a matter of notations. Okay. Any confusions that you should ask me if that is, because it is not spelled out very clearly. Okay, so that's what this means. Now I'm going to do, now I still have beta remaining. There is a sum over beta. When summing over beta, there is a 0. Beta can take a 0. Right, so let me do that. So this is epsilon Ij 0 0 F 0 0 plus epsilon Ij 0 K F 0 K plus 1 by 2 Ijk 0 F K 0 plus 1 by 2 Ijk, and let's say Ijkm maybe, like Latin, and Fkm. Clear? So again, beta has 1 0 component and 3 space indices. Beta here 0, space index m. I cannot use k because k is already used up, so I have to use m there.
Why there's only summation for the alpha and beta? What about I?
Because it's free. There is no, only the repeated index sum, remember. Ij do not repeat. Right? Only the repeated indices are summed over. So for the other cases, I'm choosing them, I'm evaluating them. That's the third component of a vector, for example. Okay. What is F00? 0? What is F00?
0.
0. Good. And what is epsilon Ij 0? That's also 0. So let's not worry about this. Independent of that, that's equal to 0, right? Because it's repeated. What about this quantity in here? What is that equal to?
Just the epsilon.
Yeah, just the epsilon here. it is a number. Even though it's a tensor of rank 4, it's a nice tensor. Oh, that's tricky words. What is that?
1.
1. You also said +1? Okay. No. Why is it +1? Maybe I should ask.
Was 0, 1, 2, 3 was once.
Even permutation.
Rethink, that's the wrong answer.
It's 0.
That's correct. And why is it 0? Hopefully it's not a
It's
guess.
If it's not 1, it's 0.
Ah, come on, that's a guess. Okay, now I reveal the answer. Now tell me, why is it 0?
Because it's for Latin was 3 indices, so one of them is repeating.
Yeah, this has to be repeated because these are 4 indices, but these are all Latin. So I have only 1, 2, 3. So I can choose 1, 2, 3 here, then next one has to be 1, 2, or 3. Right, so it has to repeat. So it will be 0. Right, this is equal to 0 because they are Latin. Good. Okay. So 2 of them gone. These 2 are pretty much the same, notice. K0, I can, if I interchange these 2, I get a -1. But then this is antisymmetric, I can change this also. Right, so this is 2 times. So that's equal to, let's say I start, then what should I do? Which one should I choose? I like, yeah, let's move 0 to, so let's say this is epsilon ij0k and f0k. That's this. And here I change this. I gain a sign. I change this. I gain a sign. That makes it 2 times 7. Clear? I move 0 2 times. So that's equal to epsilon 0 ijk, even permutations. That is good. That's equal to epsilon ijk f0k. And f0k, the 0th component of k, is nothing but the minus electric field. So that's equal to epsilon ijk minus of ek over c. Ek over c. So that's equal to -1 over c.
Can you explain the addition of the half?
This one, why the half?
No, how?
Oh, how these 2 came here? Let me write this as 1/2 itself. That's exactly this term. This term here is equal to 1/2 times minus of ij0k. If I change 1, I gain a minus sign. This is equal to minus of 0k because this is antisymmetric. Like this was antisymmetric by construction, so if I change, I gain a sign. These 2 cancel away, and then these 2 are exactly the same. Okay, so that's the antisymmetry coming in, and then I use 0 twice, I swap twice to go from here to there. Okay, is that clear? All the tiny intricate steps there?
Shouldn't that be 0k ij
0k I
to the next line?
here.
Yeah, from that.
I changed 0 and j first. So let's say this you agree, right? So epsilon ij0k is equal to minus of epsilon I0jk. Right? And that's equal to, again, I change 0 and I. It's plus 0 ijk. It could be the other way also. I can also, this is also equal to, if I go 3 times, it's equal to ijk0. That's also true.
Because for 1, 2, 3, it was cyclic. It was 1, 2,
Yes,
3.
I should warn, we get used to that. In 3 dimensions, cyclic works. 1, 2, 3 is the same as 3, 2, 1. 4 dimensions, that doesn't work. It's no more cyclic. That's why I changed. I first wrote cyclic and then I changed it and said even permutations. Here you have to be strict. In 4 dimensions, use permutations. It is permutations that is the basic thing, but in 3 dimensions, cyclic and permutation are identical. But in 4 dimensions, cyclic and permutations are not identical. That's good. Okay, good point. That's what pointing out. Good catch. Like what I think, in case anyone missed that, notice 1, 2, 3 is equal to 3, 2, 1. 3, 1, 2, so 3, 3, 1, 2, right? There are 2 ways of seeing this. One is that I first swap 3 and 2, then I swap 3 and 1. 2 swaps, that's even permutation. Or I can say it is cyclic, right? 1, 2, 3. So that's a cycle. Correct? I can say 3, 1, 2, 2, 3, 1, they will all be the same. So cyclic and even permutations are the same in 3 dimensions. Now look into 4 dimensions. 0, 1, 2, 3 is equal to, now let me make it cyclic. So this is 3, 0, 1, 2. That's cyclic. Right? But notice I have to come once here, twice, thrice. So it's a negative sign. So cyclic and even permutations are not identical in 4 dimensions. They are identical in 3 dimensions. It's the same thing. You don't have to worry about permitting. You just go. So you just check if it is in cycle or not. Is that clear? Did I clarify that? Good. Good point. Okay. So what we have here is that C. Let me write this down here. So C times F tilde mu nu is equal to 0. So that's your F0. I am writing the bottom one, right? By the way, what happens when I write the bottom one here? F tilde ij. This doesn't change, right? These are all space indices, doesn't matter. So it is 1 over C epsilon ijk. If you want, since you're writing up and down, you can write it K, but space index doesn't matter whether you go up or down. So that's what it is. So this is equal to, I'm here, so this is equal to, since I multiply by a C, so it's a minus CB1 minus CB2 minus CB3, and that's equal to 0. Now 1, 2, 1, 2 means 3, right? So this is E3. So that's equal to minus, what are you calling minus? I guess it is minus, maybe. Let me check. Well, yeah. Yeah, minus. So this is slightly different. Yeah, okay. So notice there's a slight difference. This is plus, this is minus E3, doesn't matter up or down. And this is plus EQ 0 and minus E1. Okay. And the antisymmetric piece associated with it. And now you see why that's called dual field tensor. This seems to be, that is this feature that you can start from here. And what I'm doing is that electric field is being replaced with magnetic field. Right. But the magnetic field is being replaced with negative of the electric field. This is called the dual symmetry. This is there in the Maxwell's equation itself. the whole of the Maxwell's equation, and as all of physics, as far as we have seen, because Maxwell's equations are building everything else, this symmetry exists everywhere. If you try to change electric field to magnetic field and magnetic field to negative electric field, everything remains the same. Like tomorrow onwards, tomorrow early morning, let's say that you replace everywhere there is an electric field with magnetic field in your textbook, and all the magnetic field with the negative piece of that, all the equations will stay the same, all the effects will remain the same. You will not be able to make any distinction out of it. That's called a symmetry. So this is called dual symmetry. And this has more to it in the sense that you can think of it as a rotational in a plane, but we won't go in the quiz. Look up dual transformation and its connection with monopole, magnetic monopole. Like, what is dual transformation or dual symmetry, and what is its connection with magnetic monopoles? Like we said, we have a quiz. Okay, all this was constructed assuming that I wanted these two equations to combine, correct? So I constructed the potential, I constructed a field tensor and said that, oh, the derivative of this field tensor is equal to the source. Now, what about these two equations? They were missing, but the claim is that this tensor allows us to write that. So let's consider the construction exactly like we had earlier. Let's ask what is d nu f tilde mu nu equal to. What is that equal to? Let's ask that. Question?
For the quiz, you said connection with magnetic monopole or dipole.
Monopole. What are dual transformations, and what is the connection between dual transformations and magnetic monopole? Yes.
Before cleaning that side, we need to turn the camera off. I think we didn't get that part,
Oh,
the last part.
Was a matrix.
good observation.
So it's not-
Otherwise, you go back and, oh, where is the quiz? Right. Yeah, good point. Yeah, this at least helps with the quiz, right?
yeah.
I mean, there should be a software which says that every time you say quiz the word, then it catches up, right? You directly, otherwise you have to keep searching for it. When did he say quiz?
What software is that?
I don't know. Design it. I mean, that whenever there is a need, you have to build it, and then that's how good softwares come up, right? When there is a need and you come up with it. Like these days, they're pretty good recognition software. Or ask Chat GPT to do it for you. Have you guys heard about Chat GPT? It's everywhere these days.
Yeah.
Every other conversation comes up with it.
Can we upload a file? Chat.
Probably. I have not yet tried it, but a friend of mine really talks a lot about it to me. Can you upload a file? Video. I don't know. I think you
think we
can
don't have
upload
that
because he used to say that if you give it a file, it will create content for you. Like, for example, you give it a document and you say that summarize this in 3 sentences.
Yeah.
And apparently it does that. So probably you can upload a file. So probably you can upload a YouTube video. It'll be funny if you,
There are paid.
but then it will take a
websites.
long time, right? Yeah.
There are paid websites that can do like providing a video, they're writing transcript for you.
Probably. Yeah, I am not really aware of any of this, including ChatGPT. It's just a friend of mine.
I think it's for the premium version.
Maybe I
I like
really
free
don't.
version.
I've still not typed a single word. I've not had a conversation with ChatGPT yet. So yeah, it is an answer to the discussion that can you have, but build one.
You can ask ChatGPT to build one.
Yeah, that's the standard discussion that goes in, yeah. Can they write programs? Yeah, good point. Okay, let's do simpler things. Okay, so. So let's set whatever we did here, right? We used to set alpha equal to 0, alpha equal to I. So let's do mu equal to 0 first, right? Or even yeah, let's do it. Okay, in quiz, you set mu equal to 0, find the equation, okay? So I'll do a simpler one. Find the equation. Right? When mu was equal to 0, I got this equation, correct? So in this case, this will come out to be this equation here. Right? Show that. Set mu equal to I, find the equation. So you'll get the two Maxwell's equation. So I'm giving you the answer there. So that's quiz. But I will do it in a more elegant manner. So d nu f tilde mu nu, or in a more single step, that's equal to d nu times 1/2 epsilon mu nu alpha beta. Think so? Oh, can I do this really? Maybe not. Okay, we'll see. Yeah, I think so. Yeah, mu alpha beta and f alpha beta. That's what this is. And that's equal to, these are all numbers, either 0 or 1. I can bring it out. So that's equal to 1/2 epsilon mu nu alpha beta d nu f alpha beta. But the field tensor had this particular definition in here. Okay, so that's equal to 1/2 alpha beta d nu e alpha a beta minus d beta a alpha. Right. So that's equal to, let me write this as mu alpha beta d nu d alpha a beta minus of 1/2 d nu a beta. Sorry, what did I do? E beta. A alpha. Correct. It's clear what this should be, right? Or if you, for consistency, what should this be equal to? Like for consistency, when I set that, find the equation, that comes out to be 0, this comes out to be 0, this should be 0 in principle. But why should this be 0? Notice what is happening here. So what is happening here is that there are two partial derivatives coming in. And if you have dx dy, derivative of x with respect to derivative of y, it doesn't matter on the order, right? So it is symmetric. Derivatives are symmetric. This is antisymmetric. Symmetry and antisymmetry cannot stay together, right? So it has to be 0. That's one way of arguing. But let's do this in a more formal or more tedious way that we look into the details. Let's do it algebraically instead of geometrically saying that it is antisymmetrism. So how you do all this, keep this the same. This is new. I would like this to be alpha if I want to compare it with this. Correct. So, but these are all summed indices. So alpha and beta are summed indices. So let me call all the betas as alpha. So beta I'm changing to alpha, so I have to change this to alpha. And alpha I'm changing to beta. That's beta. Is that clear what I did there? These are dummy variables, these are summed variables, so I can call whatever I want to. Right, so I, B I is the same as AJ, BJ. Because it's summed, it is a summation index, it doesn't matter. So I'll replace alpha with beta and beta with alpha, with the purpose that then I can compare them, right? So then these three are the same there. So this is equal now to 1/2 epsilon mu nu alpha beta. These are now the same, right? So this is equal to minus epsilon mu nu beta alpha. Oh, level. Oh. G nu. What happened? Let's see. D nu, D alpha, A beta. Right. Help me. Yeah, alpha beta, D nu. The D nu got 10. Alpha beta. Oh, I wrote this, no, beta, no, it's correct. Beta gets alpha. Alpha got beta. Answer is supposed to be 0. Yeah, it doesn't go to 0, right? It should go to 0. So this is 1/2 times epsilon nu alpha beta. I swap this. So this becomes plus, correct? Yeah. Right, and then, oh, maybe one more step. Okay, sorry. Maybe I was doing, yeah, not the best way of doing this. Okay, keep going. Sorry. So that's equal to, so 2 times that. So that's epsilon mu alpha beta and d nu d alpha a beta. Correct? I think so. But yeah, I can use it here. Yeah, nice. Yeah, okay. Let's keep going. This will work out. Fine. Okay. That's equal to, I was doing this wrong in the sense that I should use the symmetry in this, right? So I'm not using the symmetry at all. There's a conflict between symmetry and antisymmetry, so I use that. So, okay, so let's write this again. Mu alpha beta d nu d alpha a beta, and this is 1/2 plus 1/2 d nu d alpha a b. Might have been possible to do this in a clever way, but I'm probably will get it anyway. Okay, now again change this. This time really make, this is the symmetry piece here, right? Make this work with these two, right? So I'm going to change this to alpha, change this to nu, and do the same thing there, right? Nu to alpha, alpha to nu. So that's equal to 1/2 epsilon nu, keep the first one intact, d nu alpha a beta, and write that again, 1/2 epsilon mu alpha nu beta d alpha d nu a beta. But these two are symmetric, so I can change this order. Bring this back in here, which is exactly the same as this, as far as the coefficient goes. So that's equal to 1/2 mu alpha beta. Writing again and again. But hopefully that helps. So this is, I can interchange this. This is now I'm using symmetry. The mu, the alpha, the beta. Right, symmetry. Go back. 1/2 epsilon mu alpha beta plus epsilon mu alpha mu beta mu. Sorry about too many steps, but just clarifying what I'm doing. Usually,
And now you're going up.
I'm going up.
I'm behind.
Sorry, yeah. Okay. Usually I'm going down. Okay, so this is the same as 1/2, just for completeness, writing it down. Minus, I'm changing, using antisymmetry now, mu alpha beta. That's the same, so it's equal to. Okay. Else. I think one could have been clever enough and seen it here itself. Yeah, probably use the antisymmetry in this somehow. After that. Did not see it here. So this is all good. We have two tensors. And remember, how does a vector transform? In Lorentz transformation, the time component can change in some way, the space component changes another way. Now, the electric and magnetic field are parts of a tensor, so they transform in a different way. With me? Questions? And what that means is that this whole thing is equal to 0. And that's your Maxwell's equation, or the two of the Maxwell's equation, wherever it is 0. That's your these two Maxwell's equations. So that's your first two Maxwell's equations, and that's the third and fourth Maxwell's equation, the way you label. Usually you say this is first and fourth, the way at least I highlight it, and those are the second and third. Okay. Any questions there?
So can we get the Maxwell equation mathematically with this calculations?
Yes, that's your homework. Is this what you mean? Mathematically means?
Because it was basically from experiment. They found Maxwell equations.
Oh, no, okay, it is not really mathematical in the sense that what you're trying to say is that if there exists an antisymmetric tensor, then you can write Maxwell's equations in this manner. It's a way of writing Maxwell's equation in a covariant form. I don't think you're mathematically deriving it because remember when we said this is equal to the electric field, you're using the idea of Maxwell's equation. And when I really set it to the right hand side, I identified it using the Maxwell's equation. So I got this by using the standard Maxwell's equation. So no. Maxwell's equation cannot be derived. I don't think so. But Yeah, in a sense, it can be in the sense that sometimes you say in classical mechanics, you write the Lagrangian and you minimize the Lagrangian and you get your equations of motion, Newton's equations of motion. Similarly, you can write the Lagrangian for the Maxwell's equation and you can do stationary action principle or least action principle, and you can get the Maxwell's equation. That's very much possible. But that's just restatement. Somewhere you assume something. And we will talk about that very little. I don't think we will go in detail there to write the action, but I will at least use that action a little bit in a hidden way. So I can, since you pointed it out, I can clarify or I can mention that, oh, this term that you see is the Lagrangian. So Lagrangian is, or simple, okay, how about this? Yeah, Lagrangian, if for the Maxwell's equation, typically Lagrangian is L, right? What is script L? Anyone, by any chance, has come across?
And function operator. The function operator. Function operator.
Function operator, no. Notice what happens is that in classical mechanics, the action is dt times L, right? The Lagrangian, that's how you will define, so that's your action, Lagrangian, and there is a time derivative in there. And what does your action depend, Lagrangian depend on? What are the things it depends on?
Velocity.
Position, typically, let's say let's say vector, right? So this is R as a function of time. Right, and then you have velocity as a function of time, so it is rate of change. So let's say derivative, right? dr, the function of time with respect to t, and you have the time derivative also, right? Everything is time dependent, and that's your Lagrangian. But now when you're doing electric field, notice whatever, let's say L, right? Or whatever, what are the quantities it depends on, that is electric field instead of position. Now we're talking about electric field. What does it depend on? Position depends on time. What does electric field depend on? Charge. It depends on position and time. That's what I meant. Like it depends on position and time, right? Yeah, it depends on charge also. That's so you answered it correctly, but that's what I had in mind. It depends on position and time, and it depends on the derivative of the electric field. Let's say it's a magnetic field. Remember, magnetic field is nothing but the derivative of the electric field. So in a sense, that's your velocity operation. But now there is 4, right? This was time dependent. There are 4 things you have to integrate on. It's space and time. Time is time. So you integrate over dt and on dq bar. And whatever is remaining, so now this is called curl of L. It is a Lagrangian density. Right? Invariant quantities. in under boost. Boost means under Lorentz transformation. Electric field changes, magnetic field changes, charge density changes, current density changes, all of this change, but there are certain quantities that does not change. And that's what we will be interested in. And we will find it by finding the eigenvalues of this matrix. The eigenvalues of this matrix does not change, and first we will demonstrate that under S Lorentz transformation, its eigenvalue does not change. And then it's just a matter of finding the eigenvalues, which is hard because it's a 4x4 matrix, but we will use tricks to get the eigenvalues. And eigenvalues will be written. One of this will be this factor, and the dot product of magnetic field and electric field will come in, and that will be the second. It's not an eigenvalue to be written in terms of that. And that will have a lot of implications of what are the configurations possible. Maybe I can ask quiz. Okay, what is the Lagrangian for a photon, for an electromagnetic wave, plane wave, electromagnetic plane wave? Evaluate this quantity. Do you know it right away from your head? What's the property of a plane wave, electromagnetic plane wave? Remember sine waves, like electromagnetic wave is like this, right? Is that clear? So this is your. Does that make sense?
Yeah.
Right? So keep this in mind, and if I ask you what is this equal to?
0.
That's equal to 0 because the magnitude of this is exactly equal to the electric and magnetic field are connected. So that's 0. That's the answer to the quiz that I just gave. Good, very good. And what is E dotted with B in this? Electric field
Constant.
dotted with magnetic field.
Constant.
Electric field dotted with magnetic field. In this case, 0 because they're perpendicular. Right, so it's also 0. It's constant, of course. If it's 0, it's constant, but it's also 0. So keep this in mind. We'll talk about this on Thursday, and it will be a solution by one of them.
Can you switch to this board?
Oh, quiz.
This one?
Yeah. Are the quizzes helpful, or is it too much of work, too much of unnecessary work?
Some of them are.
Unnecessary. Some of them are helpful. Should I make it optional? Okay. Maybe. Yes, no. Yes, no, maybe. No one wants to speak out. So the election, Pravina, is it helpful? The